When we have a limiting and excess reagent problem, the form you're going to see is something like this. You'll be given an equation, and you're going to get asked this question. If given some amount, and I'm going to make it 400 grams. 400.0 grams of each reactant, which is limiting. Which is excess? How much remains? Okay? So that's the question that you're going to be asked. Which is excess? Which is limiting? How much remains? Now here's the part that you are all very good at. You are all very good at getting the right numbers. We're going to go ahead and get the right numbers. So what I want you to remember is that this is a limiting and excess reactant problem. What that means is for the purpose of this problem, we are going to completely ignore the products.
Oh.
Okay?
Like for all of these, we're going to ignore those?
For right now, we're going to completely ignore the products. Okay? So we're only going to compare the two reactants. Now let me ask you a trick question. I don't want you to yell this out. Jot it down on a piece of paper, and then you can compare notes with someone near you. What's your given in this problem? What is your given? Tricky, tricky, tricky. What's your given?
I don't know.
Okay, how many of you think you know? How many of you have an answer?
I have two.
Okay. Mr. Cooper, tell me what our given is.
I said I have two. I have no idea which one. I don't think they're either. But I say either 400 or 800.
Okay. What would you say?
I'd say 400 grams of each.
Okay, that is exactly the wrong answer. That's exactly what I wanted you to say. Thank you. That's perfect. So how many of you were thinking the same thing? Well, the given's 400 grams of each of them. Is that what you were thinking?
No.
Okay.
No,
Okay. Well, that is exactly the wrong answer that I want you to have, because it's correct in one way. Each of those is a given. You are being given 400 grams of ammonium sulfide, and you're being given 400 grams of calcium phosphate. You do have two givens. Now, with that said, what do we start off our factor label with? The given. Well, now we have a problem because we have two of them. Which one do we pick? Guess what? Doesn't matter. You're gonna end up doing them both. Yes.
Oh.
No whining. There's no whining in chemistry.
Are you sure there's plenty?
Well, yeah, actually there is. Okay, so what we're going to do is we're going to pick one at random, and we're going to do a factor label that compares our two reactants. So I'm just going to start with the first one. Let's start our factor label. So 400.0 grams of ammonium sulfide is our given. Now, let's get through our whole setup here. Units in chemical, here, somebody with a hoodie. There are 3 of you, 4 of you.
Units, those are the units are grams of ammonium.
Yep. Grams of ammonium sulfide. Okay, units in chemical up top, somebody with buttons above the waist.
We all have belly buttons.
Not that kind of button. Nobody's wearing a button-down shirt? Okay. Okay, somebody with, okay.
What are we going to?
Well, we're going to compare the two, that's a great question. We're going to compare the two reactants. And we know we need to be comparing them in grams. So this is going to be gram to gram.
Those are wrong.
The whole way across,
You
yep.
know what? It is okay.
It's okay.
What are we
It's all orderly and structured. We're going to compare how much of this reactant can fully react, how much of that reactant.
So are we trying to go
We're going gram to gram.
grams of
Yep.
So,
So-
that to go with that.
Here we've got grams of ammonium sulfide. Here we've got grams of ammonium sulfide. What's our units in chemical up here, Mr. Kane?
Moles of ammonium.
Moles of ammonium sulfide. Okay. Units in chemical down here. Somebody who has had a hamster at some point in their life.
oh, wait.
Anybody have a hamster or a guinea pig?
Oh, I'm already.
Moles. Oh, good. Moles of ammonium sulfide. See, this is a nice. I get to know you guys too. Okay. Units in chemical up above. Somebody who likes snakes.
Oh.
Do we go to moles of
Mm-hmm.
whatever that equation? Yeah, that.
What is that?
Calcium phosphate.
Yes, moles of calcium phosphate. Good. You thought you were going to get away with saying whatever that stuff is?
Yeah.
Not a chance, kid. Okay, now we're going into grams of calcium phosphate. So, units and chemical down here. Somebody who's left-handed. No, oh, that's right. I tried that the other day. That's right. Okay. Units in chemical. Somebody who has on shoes without laces.
We don't have to.
Okay.
Moles of calcium phosphate.
Moles of calcium phosphate. Okay, and units in chemical up here. Somebody who hasn't said anything yet out loud today. Grams of calcium phosphate. Oops. Messy, messy, messy.
It's okay.
Okay, now let's start plugging in numbers. On these problems, especially when you're doing them, because they are a little bit involved, I'm going to strongly recommend that you make a note to yourself over here with your molar masses. 32.07 sulfur? Yeah, 32.07.
Yep.
And we're going to figure out calcium phosphate also. Ca 40.08 times 3. Phosphorus 30.97
And we please sit down, I guess.
No.
times 2. Oxygen 16 times 8. Oh, it's a circus.
I did, but not anymore.
Okay, 68.17. And what do we get here?
That's like 60.
68.
Are we doing a lot of these on the board?
We're going to do a fair number, yeah. Okay, 310.18. All right, so now let's plug in some numbers. This is a mole ratio, so what number is going to go with our moles in a mole ratio? Or, I'm sorry, this is a molar mass conversion. 1 mole, and then we want our molar mass, 68.17. This is our mole ratio. Where are we going to get the numbers? In the balanced chemical equation. So 3 and 1. This is another molar mass conversion. So it's 1 mole and our molar mass. Okay, so get me a number. You're all good at this. Okay, when you have a number, compare it with somebody near you. I have absolute faith that every single one of you is going to get the correct number for this. Okay. Anybody have something that looks like 606.7 after you say fig it?
Anna, what did you
No.
Yep.
I do.
Exactly.
Anna, what did you do?
Do it. Don't talk. Shut up, Josh. You can do it. I'm not looking.
Okay, 606.7 grams of calcium phosphate. Good. Most of you got the right answer, right?
I got it.
All right. Probably a math error if you didn't.
This is my calculator.
Now, what the heck does that mean? Because in limiting and excess reagent problems, getting the right number is only the first step. You can get the right number and get the wrong answer.
Of course you can.
Okay. Here's what I'm going to tell you. I struggled with these in college.
Awesome.
I've watched students struggle with them. No. I am going to give you a way to never screw this up. I'm going to give you the magic golden key to never, ever miss this problem once you have the right number. What you're going to do is you're going to write yourself a sentence. So, here's how this is going to go. Blank. Can fully react blank however. Now, this is the first part of this sentence, and this first blank is the given that you started this factor label with. So this blank is 400 grams, it's 400.0, but I just got sloppy there, of ammonium sulfide. Can fully react, and this blank is the answer that you got. Because what we're doing is we're telling the story of this problem. So 400 grams of ammonium sulfide can fully react 606.7 grams of calcium phosphate. However, the next part of this is we have blank. And you're going to get this number from going all the way back up to what you were originally given. Okay? So how much calcium phosphate were we given originally? 400 grams. But we have 400 grams of calcium phosphate. Okay? Then, this is like a multiple choice question that you have to answer. Therefore, one of two things is going to happen. Either A, we will run out of it being whatever this is, or B, we will have blank grams left over. Okay? There are two ways that that sentence finishes. So in this case, 400 grams of ammonium sulfide can fully react 606 grams of calcium phosphate. However, we have 400 grams. So, what's going to happen?
Wait, can we just...
We would have
Yeah.
no.
No.
I'm confused.
Okay, these are a little bit confusing. That's why we're going to spend all day tomorrow on them. This could fully react 606.7 grams of calcium phosphate. However, and I'm going to put in one other word, we only have 400 grams of the stuff. We could use, so this is like saying you got a chocolate chip cookie recipe. Our chocolate chip cookie recipe calls for 2 eggs. We've got enough flour and sugar and chocolate chips and everything else. We only have 1 egg in the house. 3 cups of flour can fully react 2 eggs. However, we only have 1 egg. Therefore, A, we will run out of it. B, we will have eggs left over. A.